Hello and welcome to today's video. Today's video is for Advanced Geometry Chapter 6, Section 4, Special Parallelograms. So the theorems we are going to learn today are about special parallelograms. So the first one we have says that the diagonal of a rhombus bisects the two angles of the rhombus. So if I draw a rhombus and then I draw one of the diagonals, so my rhombus doesn't look very rhombus-like, but imagine it's a rhombus, and I draw one of the diagonals, then this diagonal bisects the two angles. So I'd know the top two angles are congruent and the bottom two angles are congruent. Now something else I'd have to use another theorem to prove it. I also know all four angles there are congruent because opposite angles are congruent. So if both of those diagonals bisect the angles and the angles are congruent, then I could prove that all four angles were congruent. So this one I call the rhombus diagonal bisect angle theorem. And if you left off the word angle, that'd be okay, because we do have another diagonal theorem, but it deals with perpendicular. So as long as I see the word bisect, I know what theorem you're saying. But most of the time I call it the rhombus diagonal bisect angle theorem. Okay, and that one we will prove in class. So the next one we have also deals with rhombuses, and this one says that the diagonals of a rhombus are perpendicular. So this one is called the rhombus diagonal perpendicular theorem. So, and remember, because a square is a rhombus, this would also be true for any squares. If I was doing a proof with it, I would have to first say the square was a rhombus so that I could use anything that I know about rhombuses. So be careful that if you're given it as a square, you don't say the diagonals bisect each other by the rhombus diagonal perpendicular theorem and never actually say that this square is a rhombus by definition of a square. So here's a little algebra problem. So we're given a rhombus and we're given the measure of angle n is 120. Find the measure of all the numbered angles. So one of the things we know is that a rhombus is a parallelogram. So we know that the sides are going to be, opposite sides are going to be parallel. So we know that the measure of angle 3 plus the measure of angle 4 is supplementary to 120. So that is going to be 60 degrees. And then we also know that measure of angle 3 equals the measure of angle 4. So the measure of angle 3 equals the measure of angle 4, and they must both be 30 degrees. And then also, because 1 and 2 are also congruent, and the sum of them is congruent to 3 plus 4, we also know the measure of angle 1 equals the measure of angle 2 is also 30 degrees. So if that problem was on a quiz or a test, it would obviously involve quadratics and things like that, but the basic idea is the same. Okay. The diagonals of a rectangle are congruent. So if we have a rectangle, the diagonals are congruent. So this one is rectangle diagonal congruent theorem. Okay, and we'll prove this one in class. One of the things that you're going to have to know is you're going to have to know, of course, which one of these theorems go with which figure. And as soon as we're done with section 5, I'll give you a nice worksheet that, which ones are the diagonals congruent, because we do have another figure that we're going to learn where the diagonals are congruent. Which one do the diagonals bisect, which one do the diagonals perpendicular, things like that. So for this one, to decide if the parallelogram is a rhombus or a rectangle, if one diagonal of a parallelogram bisects two angles of the parallelogram, then it is a rhombus. So this one is the converse of the rhombus diagonal bisect angle theorem. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So this one is the converse of the rhombus diagonal perpendicular theorem. And the last one, if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So this is the converse of the rectangle diagonal congruent theorem. Now, one thing I want to point out, we haven't done the next section notes yet, but notice for each one of these you do have to have a parallelogram. So like I mentioned, there's another figure where the diagonals are congruent, but it's not a parallelogram. So make sure if you're going to use, especially this last theorem, that you have a parallelogram before you say, oh, it's a quadrilateral and the diagonals are congruent. It has to be a rectangle. It has to be a parallelogram in which the diagonals are congruent. And that is it for today's notes. Thank you for watching. Have a great day. Take care.